Hello and welcome to another episode of Risky Business. So as for latest news, I've posted now on Twitter. You can see here the Handmade-network's tweeted about it, Handmade Seattle's tweeted about it. They put up the Handmade Seattle site has the latest newsletter announces all the projects that will be there, which includes Risky Business. And so yeah, they posted their updates about that. And then Handmade-network went through and shouted out all the the projects from the network that are involved in the conference. And so I've posted on Twitter now my official announcement that I'm going to be at Handmade Seattle. So you can see that here. I put together a little ad showing off that we're going to be there, and that there's going to be the risc-v PC and the bookmarks and everything. So there's that. And then I also posted on Twitter my my CAD model files. So if people want to correct our measurements if we've made mistakes, or if they want to add details to the model, I'm happy to take pull requests for that. And yeah, that's pretty much it. Let me show you. Whoops. Okay, let me show you the latest news for the Handmade Seattle. So here we have the details of everything, and like I say, here's the list of the projects that have booths and everything. The other thing, so speaker topics, we have Mike Acton is going to be speaking about data-oriented design breakdown of an object-oriented programming sample. So I guess he's going to take some object-oriented code and transform it into something better, show us how you can apply the principles of, data-oriented design to, write better code than what people in the object-oriented programming world are doing. So that should be fun. And then this one, Good Times with a Pile of GPUs. I'm not familiar with the speaker, but I believe it said they're from Unity or something. So that should be interesting. Good Times with a Pile of GPUs. I don't know what all that's going to entail. How, like, if it's going to get low level into GPU stuff or what, I don't know. So we'll have to see what that one's about. And then Tom Forsyth is doing talking about Larrabee, his work on that. And that's AVX 512. That pretty much directly comes from Larrabee. That's the modern incarnation of that work is AVX 512 basically. So it'll be really interesting to hear about his work on that. He has a great blog series going over the history of that architecture, and it's a very interesting read. So that should be a really great talk also. And then Fabian Giesen, of course, he's always he's great to hear from. Lots of great technical information from him all the time. So he's going to be talking about queues. I don't know what he has to say about queues, but I'm sure it will be interesting and insightful. So lots of exciting stuff going on for Handmade Seattle there. I'm looking forward to all that. And then also there's ticket sponsoring. So of course, since I have a booth, I don't need to worry about that. But for people who just want to attend the conference, if you are in a financially difficult situation or something, and you do not have a ticket yet for the conference, it says that some generous people have offered or expressed his desire to sponsor people in difficult situations by purchasing them a pass. So I imagine you'd still have to, figure out where you're going to stay at and get, flight tickets and whatever else. But at the very least, you could get a free ticket potentially if you're, in an unfortunate circumstance. So that's a nice thing there for people. So if you're interested in that, give Abner an email. But like I say, that's these videos are just going up. They're going to be public after the conference. So this only applies to the people supporting me on Patreon. So maybe not relevant there. But anyway, that's a nice thing too. And yeah, that's pretty much all the news to go over. So let's jump into continuing our modeling stuff. So I've updated the model now. I did the usual, after recording, I cleaned up the code and, refactored things. So let's go over that. One thing I did a little bit was I played around with the shape we were working on last time. We left off with this, we figured out the shape, but we still had kind of like a rectangular region in here. And I was saying that, we can probably switch that to just be like a circle and it'll do what we want. And I tried that off recording, and it indeed is exactly what we want. So I'll go over that first, and then I'll go over the refactoring I did. So, and then here, let me also, well, no, I don't need to fire up act on it yet. I'll start it, but okay. So, as for the shape we're working on, so basically, here, let me turn off all this stuff. Okay, now, as for this shape, basically what we've done here is, I believe, yeah, this line right here. So, we've done an intersection in here. It used to be intersecting with a square, and I just changed it to circle, right? And that's all you really need to do to achieve what we've done here. So, right, if I comment that out, you see there's the the original shape, and literally all you do is you just do an intersection with a circle. So you just make a slightly bigger circle, and then say intersect with that, and it'll chop out all this stuff. So just like this. So that is looking perfect. And then as for everything else, if you look here, the biggest refactoring that I've done is, you'll see here, I've created a ramp edge thing. So I've turned that into a module. So by ramp edge, I mean the shape we're doing right here is a corner, right? And these kind of slanted ramps is what I'm calling them. These pieces I'm calling ramps. So this is the ramp edge, and so yeah, I just, since we had that copied and pasted, like 1, 2, 3, 4, like 4 of them already, and there's going to be more. There's still, we need one like here, Well, I guess we just need one more and then we delete these two or whatever. But anyway, we have a bunch of these ramp edges, so I figured, let's actually, refactor that into a module. And so the nice thing about module is something that we haven't done yet with modules. I wasn't sure you could actually do this. I looked it up in the documentation and you can. So I'm glad you can actually do this. You can pass variables into a module, so they can be parameterized basically. So for my ramp edge module, I just pass it the radius of the cylinder, and then the length of the thing, which is the height of the cylinder. But it it translates, it turns into, for our ramp, it's how long the ramp is basically. So I default it to 16 for the radius and 151 for the length, which is just how big it is for these long ones here, So that's what I set the default to be. And then you can see in here in the code, it's just the same thing we were doing before. I just parameterized it. So now the height is being set to the length variable, and the radius is being set to the radius that we pass in, and that kind of thing. So now whenever I want to ramp, I can just instantiate the ramp edge module, and that saves a lot of code. We're going to do the same thing to the ramp corners too, of course. So if you look here, you can see for this one, we just do a default ramp edge and then we translate and rotate it into place. We do the same thing here, and that's this one here and this one here, right? And then this one here, the tiny one, you can see what I've done is I've just changed the length from being the default 151 to 70, and other than that I kept it all the same, and then translated and rotated that into place, right? So that's how I'm doing all of these, is you're just instantiating ramp edges now. So that's pretty slick. And then yeah, and then like I say, for the experimental stuff we've been working on, again, these are just instantiations of the ramp edge module. And then other than that, I've cleaned things up more. So I've put my modules, I've nested them more deeply. So like inside the guts module, we have the definition for the expansion board module, and instead of calling it exb, I've renamed it to expansion board, so it's clearer what we're working with here. And then similarly, inside the guts, we have the High Five Unleashed module, which has been renamed from HU to High Five Unleashed. Yeah, we have the bracket module, of course, which we already had like that. It has a front and a lip. And then we have the USB card, which again, I've renamed to USB card. It was just USB. And then the graphics card has been renamed from GFX to GFX card. So I just made it a little clearer what all the pieces are and scoped them more tightly. And there you can see, here's all the code that assembles them together. And then, like I say, I made the ramp edge module. And then for the bottom of the case, I've put that code into a module now. So I have a case bottom module, and eventually the ramp edge is going to be moved into the case bottom module, but it's outside of it right now because I'm using it in the work in progress stuff. And when I do work in progress stuff, I tend to just stick it in the, the outermost high level scope, and then I scope it more tightly once I've finished it up as a refactoring. So that's what I've done here, you can see. And that covers all the changes we've done since the last recording, the last episode. So let's get back into working on this here. So let's just make sure, first of all, that when we move this piece into place, it fits in perfectly, right? We want to make sure we can we've got the right piece and it lines up. It looks like it should, but you know, we're going to confirm that. We're going to actually, you know, line these all up correctly and make sure it all fits together perfectly. And then once we've got that confirmed, we'll you know, actually start putting them in the final model here. So we'll do another ramp edge on this side, and then we're going to need to put corners right here, and then, you know, here and here. And then once we have those done, we can do the rest of the skirt. And once the skirt is done, we can start, you know, adding. We're going to do some cutouts for the region where the SSD sits. I'm going to do some little cutouts on the bottom of it here to just to say, like, you know, have some ventilation, right? Some ventilation strips cut out of the bottom there, so that air can flow, because the SSD is like it gets pretty hot, you know, and it doesn't have any cooling or anything. And so we're just going to have you know, that region opened up a little bit so it can breathe. I think that's a smart idea. And then yeah, and then we're gonna, you know, add some kind of like plastic standoffs on the bottom of the case on the corners to have it sit a little bit above the ground, because, you know, like this right now, this is our ground level, but there's going to be you know, screw heads sticking out here, and we want it to be able to breathe too. So we definitely want to, you know, extrude some, you know, some little stand points, you know, some feet. We want to give it feet, basically. And then we're going to do walls along the outside of it, and then we'll do the top part of the case, which is basically just going to be a big box, a hollowed out box. And then we need to do the last thing, which is making snap, you know, snap to fit details. We're going to need to work out exactly how we're going to do that. That's the last major piece of the puzzle we need to work out here. And once we've done all of that, it will be done, and we can send it off to manufacture. And then it's going to be about a week of turnaround time, I'm expecting. So a week from then, we should get our parts, and hopefully it all fits together and works. So that's the plan. Let's start with this. So we're going to want to move this corner into place here. So okay, so we want it to go in sort of like this. Or is that not doing what I want? Let me get a nice view of this. Okay, well, first of all, okay, yeah, that was not doing what I wanted. So first of all, let's line this up. Okay, that's too far. Okay, yeah, 16.5 lines that one up. Yeah, this is too big, I think, but let's Let's look at it from the other perspective first. Okay, yeah, so yeah, this is too big. How big are these ramp edges? $16. I have R equals 16 for this. Oh, but this is set to 42. And the circle is 40. Okay. Yeah, we need to change these to actually be, you know, based on a length and stuff like that. So let me compare. Let's set a mark up here. Okay, so we're doing 2 cylinders where the radius is the radius, and the one that we do as the difference is r minus 2. We don't care about the length. But the square is radius by radius. That makes sense. So the diameter is going to be r times 2. This is going to be r into r. Same thing here. So something like this. Where is that now? Let's temporarily turn everything else off. Okay, so this looks good, right? So this sliver should be correct. But I don't think we're rotating it into the right place. I think we want it right here. And I don't think we want this either. But rotate extrude's not working for me there. Okay, wait a minute. Okay, yeah, this much is doing what we want. We need to give it thickness, though. But, let's worry about that in a second. Okay, so it doesn't like this intersection. Oh, that should be like... or not. Okay. So if we have... What is it complaining about here? I'm not seeing my syntax error. What is the syntax error? It looks fine to me. Oh. Accidentally added a stray line in insert mode. Added a stray character, I mean. So this is what we wanted. Okay. In like half an hour, I'm going to take a lunch break. Okay, that looks pretty good. Other than this bottom piece here, that kind of flattens out in a way I don't want it to. Well, let's work with what we have here. So, first of all, let's experiment with changing R and C. Yeah, so it looks like that's all updating correctly. Set it back to 16. Okay, now let's turn these back on. So now it should be the right shape and everything. Let's see if we can't get it lined up properly. Here, let me color these differently so that we can see things more clearly. I'm wondering, maybe it needs to be thicker. Maybe not. Let's look at it from different angles. And let's turn off this stuff. Okay, so first of all, let's line this up better. So, other way. No, it's flush it. But if we look at it here, see, the thing I don't like about this is how it's losing all of its thickness at this tip. I don't know if that's really what we want. But let's keep experimenting with this. So this should be here. Yeah, and this is flush here. Oh, I see. So yeah, this needs to go out. Okay, I'm going the wrong way. So the 4 is definitely not right. That does need to be 2. But yeah, see, you can see the fundamental problem right here, basically. We want these to make a triangle. Like, we want to fill this region in. And this is just a point. So it's clearly not quite right with what we're wanting to do. We're very close to the correct shape, but in terms of extruding it out, giving it the thickness it needs, we don't have quite the right technique yet. So yeah, this is not quite right yet. Okay, so let's think about this. How do we get it to do what we want it to do? Okay, so first of all, the first question is, can we make it such that this circle lines up with this circle. And if we were to do that, it actually needs to be radius minus 2, because 2 is the thickness. I didn't parameterize the thickness. We could parameterize it, but we don't need to for our model, you know. And the general rule of thumb with programming, and I'd say the same applies to this CAD modeling thing, is you do not ever want to over generalize things. That's a waste of time. You know, unless you need the generalization for what you're doing, then it's a waste of time. You know, libraries are a thing that's very useful to a large number of people, and the thing about that though is then they need to be very generic. But for application code, you just do the thing that's specific to what you're doing and nothing more. Otherwise, you're just wasting time. And there are a bunch of libraries for OpenSCAD, which would maybe make our job easier, but we're just doing everything from scratch. But that's also, I think, one of the big drawbacks of libraries is because they need to be overly generic, you end up with stuff that, like I say, is very generic, but not necessarily exactly what you need for your application. It's, you know, it might be doing things that are unnecessary because they're necessary for the generic case that you don't necessarily need, you know. So anyway, so what I need to do here is I need to say this innermost circle, it needs to be -2, like that. And it looks like that actually does more or less exactly what we were hoping for. So if we move this in a little bit, the thing is, it's not perfectly lined up yet though. So it seems like we're still not quite there yet. But that's the right idea for sure. Okay, yeah, R-4 does what we wanted. See, that's exactly what we were looking for there. So now it's just a question of lining it up. Yeah, I think that one needs to be exactly there. Then let's move this other, the blue one. We're not translating the blue one, so let's design around the blue one instead, actually. So that means the green one needs to be moved. I think right around there. So yeah, like that. So we don't have that inner circle quite right yet. There we go. Yeah, that's perfect. Just like this. Okay, so we have managed to do it. We've managed to get the shape just perfect. The one thing about it though is we need these corners to match. You know, they need to line up perfectly, and I don't know if that's how we have it in the actual model yet, but if they don't line up like this, we'll just change it so they do, basically. I think we can do that. So yeah, we're gonna end up with this beautiful structure here. And if we change it all so they're all black again, you can see what the final result is gonna look like. Yeah. That is looking pretty nice. And then if we hit the render button, it does not show up in the final model though when we go to render the thing. It gives us a warning, object may not be a valid 2 manifold and may need repair. So what is it complaining about? I wonder if this has to do like the convexity parameter to rotate extrude or something. Well, setting it up higher didn't do the trick. So I'm a little bit concerned about this. I don't know why it considers this to be invalid. You know, at the end of the day, we need this to be something that the 3D printer can actually print. And I don't know why it doesn't like this. I mean, it's got thickness all around to it. It's the exact shape we needed. What doesn't it like about it? And this is a little bit concerning because we may be getting into territory here. We may be getting into territory where it, you know, you need to be more of an expert on CAD models and what 3D printers can and cannot work with, and how to repair them, how to repair a model if it, you know, has something that they don't like, you know, that kind of thing. And we obviously are not an expert with regards to that. So how to make this work is possibly going to be a trick here. But I am gonna be taking a lunch break here, so we'll continue investigating that in a little bit. I will be right back. It appears my recording didn't pick up again. OBS seems to be having a bug with that recently. Hopefully this one stays on. So, okay, to recap, I haven't done anything yet, I was just recapping. So I am back, first of all, and what I was saying is, you know, in the preview mode, everything looks fine, right? And this is just like a quick and dirty preview that has, you know, nice to have things for modeling, like you can color the parts and add transparent, you know, stuff and do all kinds of, you know, stuff that's useful when you're modeling a part. But the rendered view is what actually goes off to the 3D printer, and it's the rendered view that's giving us trouble. We see the part we did last is missing, which is very problematic. I'm worried that that means it's not gonna be in the final print. You know, that's a very big problem. So if we can't fix that, we're going to need to replace it with something quick and dirty, you know, just like a simple polygon type of shape, like just stick a cube in here or something that fills in the space, but it would look really ugly. So I'm really hoping we don't have to do that, because we just spent a bunch of time, you know, making a nice polished professional looking part. And it's going to be a real shame if we can't use it because of a, you know, a limitation of the program we're using. That would be very upsetting. So hopefully we can get this working quickly here. But the warning is object may not be a valid 2 manifold and may need repair, which is a very technical warning. And so we are not an expert in this and don't have time to become an expert in this before the conference. So, you know, if we can't, you know, figure out some simple change to make this work, then we're kind of out of luck, and we're going to have to do, you know, replacing that part with something simpler. So that's very upsetting, but, you know, you do what you got to do. So let's see if we can't find a simple way to make this work here. I'm suspecting it has to do with the rotate extrude, but I don't know that for sure. So first of all, let's take out this stuff and just look at our piece here. And yeah, so when we render that, still doesn't show up. Okay, so if I don't rotate extrude this is the piece, right? And if we render that, it does warn us that it's a 2D object, you know, fair enough, right? So, but when we rotate extrude it, it's gone, right? So first of all, what if we start taking out certain aspects of it, right? So So like, what if we look at this? Okay, it's okay with this. This much it's okay with. Right. So yeah, it's definitely okay when we have this, but once we chop out the cube we need, it's no longer happy. Interesting. Very interesting. So why doesn't it like that? I wonder, I'm just curious, if we take this part of it out, right, that makes it so it's like what we left off in the last episode, and then, yeah, no, it doesn't seem to like that either. Or no, it does, it was just taking time to render it, but it's okay with that. Okay, so worst case scenario, if we can't figure it out, we should be able to go with something like this at least, which, you know, wastes a little bit of material, but it's better than nothing, right? So that's an option for us. But I'd prefer to be able to just make this thing work in the first place and have it like this. So I don't know what the... Now it's not even like giving a warning when I render it now, but it's certainly not appearing either, so... But anyway, I wonder if we mess with the FN value, like let's just make that a really big value, and then see if that helps it. You know, because maybe it's just a case where it needs more fragments to be able to render the thing or something. So, okay, what's the error? An assertion from Seagal. So it's using Seagal under the hood, which I think I think that's like a computational geometry algebra something or other, you know. I don't know what it stands for, but some kind of math library that it's using under the hood to actually do the modeling. And that seems to be throwing an exception, or, you know, an assertion violation here. Incident s-face does not equal s-face const handle. So you know, who knows what the heck that's complaining about, but yeah, so doesn't like it at 500. Let's just try a really low value and see how it handles that. Okay, interestingly, it'll actually do it without complaining at a low enough value. So maybe that's the trick. Maybe just lowering the detail on the model will do what we want. Let's look at 100. I think that's what I had it at before. Let's try 50. Yeah, like it's still happy enough with it at 50. Still renders at 50. Let's, you know, see how high we can get it to go. Okay, it's still fine with it at 90. 99? Look at that. Works at 99, but not 100. Can you believe that? Seriously, it works at 99. It really doesn't work at 100? Yeah, it seems to be 99. It's the highest we can go before it craps out on us. No idea why, but let's leave that at 99 then. Okay, so let's look at all of this. So it's going to take a little while to render everything, but I want to see how it handles all of it. Okay, here we go. That's still looking good. And this is all looking good. So yeah, at least from this it looks good. I hope and pray that the 3D printer will like it. I don't really have a way to know, other than trusting what the program is telling me. It's a little, you know, a little concerning that this piece disappears at 100, but it works at 99, so I don't really know what to trust anymore. But we're gonna go with this and just hope it's good. So let me continue putting down these ramps now that we've got this business sorted out. So start a timer on act on it. And let's turn this corner into a module. Module ramp corner R equals 16. And then let's move that code up with the edge. All right, still looking good. Now, one question I have is if you look at these two here, the question is, do they meet up perfectly? I don't know if I got that correct or not, so we need to make sure we have that properly done. So let me take a look here. This looks good, but let's take a look when we turn off the guts and part of the case bottom. This stuff up here. No, that doesn't look like a perfect match. So we need to correct that. So let me first of all turn this piece back on, but then color it. You can't color a LUT block. So let's here, let's just put it in highlight mode. Okay. Okay, so you can see here what I've done is I've overlapped these to give this whole thing a bit of an overlap. What we're going to actually want to do is move it out so it doesn't actually overlap like that. So we're going to need to adjust these ramp edges. Oh, that's rotation. So yeah, that looks flush. Okay, let's do these ones. Okay, this one actually, let's go over here. Yeah, those seem to be flush. Now we need to do the same over here. Okay, I think that's good. Now we need to add in some ramp corners. So I don't know exactly where it's going to need to be. Let's just put in a wild guess. Okay, it's going to need some rotation on it. Let's give it 180 on X and see how that looks. Okay, let's give it 90 on Z, or I mean negative 90. Yeah, okay. Now okay, it's reasonably close there. Here, let's get a nice view of it. Okay, yeah, like that. Now I can see through right here, but I don't know if that's a rendering glitch or not. That might just be, it could be purely a rendering bug. Let's color them to make it easier to tell. Color. This one will be green. This one will be blue. Let's make this one purple. Let's make this yellow. Hello? Where are my colors? Why do I not have colors? Oh, because they actually have colors inside their... Or no, they don't. Oh, because I'm coloring case bottom. That's why. Okay, there we go. Okay, now you can tell that is just a rendering. Just a rendering bug. Okay. Let's do another corner. Okay. Too far. I think that's perfect. Oh, maybe... Seems like that's slightly off if you look at it there, but it's a very minuscule amount that it would be off by. Let's look at this end. We've got the same thing going on there. Did we have that kind of thing with our example here? I guess we did. Okay, well, whatever, it's good enough. Is that one off in the... Why is it like that? Or is that just the result of the projection of the thing in front of it? I think that might be the problem. That's an optical illusion. Let me take that out of here. Which one is that? Okay, yeah, so this one's flush with the bottom. Let's make sure this is actually like, what's going on here? Yeah, this one's too low. Oh, yep, it was lowered for some reason. Okay, I think that's looking good now. And again, this is just a rendering bug. So next we need to do the bit up here. So that means we need another ramp edge and another corner. Let's put it up here. So for rotating it, let's see, and this is going to be one of the length equals 70s. Okay. Or 329. And then these, this one's 16. Just guess. Okay, definitely not rotated correctly. Oh, that should be 90. And then this should be -90. Okay, now that's pretty close. Okay, that seems to be flush there. And then we're going to fill in those corners. So we're going to add 2 new corners. Okay, I think it looks right at 151. So like this. Yeah, it seems pretty good. Let's see how the final render of that looks. All right, exactly as expected. So I'm happy about that. Okay. So let's turn all this stuff back on. Okay, that's an interesting point though. I guess on this end of it, we don't necessarily want corners quite like that, do we? I had not considered that. But we want something on this end. Maybe it's just not corners. Okay, which ones? Yeah, that one and that one. Nah, I mean it is really corners that we want. It's just that we want to, you know, grow this. We want some overlap is basically the thing here. Okay, so first another thing is this is going to be farther out than where our graphics card is. Well, that's okay though. Yeah, we can make that work. So basically, if we look at where the graphics cards are, there's like this much space. Is there a better view of this? Yeah. So like this much space here. I think we're just gonna leave this skirt at the bottom level here sticking out farther. But then like the actual stuff, the actual walls of the bottom of the case are gonna be farther in than the skirt goes out basically. So let's just do the skirt now. So for that, we're going to do some rectangles. So let's say like square. Yeah, let's do it as 3 squares, and then we'll fill in the gaps basically. So square, square, square. Now, where do you guys belong? So first one. Okay, let's say, I think that's right on the x-axis, or right at the origin. It goes right to the origin. So we're going to start it at 0, 0, and then we're going to make it like, let's see. So let's do like 16 and I don't know how long this is going to be. Let's call it, just eyeball it to 200 and then translate it down by 16. And then start growing this. Okay, let's zoom in here. Yeah, we're either going to want it there or one back from there, basically. And then we're going to fill in this region by calculating the correct, you know, little region to fill it in, basically. Yeah, this is going to need to be extruded. So if we look at it, let's find a good angle here. Yeah. So you can see there, it needs to be extruded by wall Z. I suppose we should pull lol-z out into its own variable. Into like a... The thing is, we want it to bake the lol-z stuff into other stuff. Let's grab this crap, throw it in here. Pull the lol-z variable out. Set this to have z equals 2 by default. Same for this. And then basically the calculations I think the calculation is just 2 times c for this, which might be wrong because I don't know why it was 4. I just eyeballed it. I thought it should have been 2, but it's actually 4, and I didn't take the time to figure out why. So I'm guessing that for some reason the math works out that it's just 2 times the wall thickness for that. But that could be wrong because it's a guess. But for our purposes of a wall thickness of 2, it works out. So we're gonna run with that and call it good. And then for this one, that becomes minus c. And I think that's the only change we need to make to that one. And like I say, I'm not even going to explicitly pass wall-z into these, but we've just made it so that we can, you know. If we wanted to, we could explicitly now pass wall-z in as the z argument to ramp corner and ramp edge, and then when we update wall-z, it would update everything, right? That's what that refactoring was for. Now, in these ones, I'm just going to use wall-z directly. So I don't think I broke anything there. Now, next thing to do is these ones. So this one I'm going to do 278. But then for translating it, it's going to go somewhere up there. Yeah, perfect. Next up, we're going to add a little bit on this end of it. So that's going to be an x of 16, a y of I don't know how much. Just put in a temporary value for that. And then the square is going to be, let's see, okay, this needs to be 0. Now the square, or wait, the square is what I wanted. This should be 16, this should be 42. This is going to be minus 16. This I think is going to be 0. So yeah, you can see that's exactly what I wanted there. Needs to be a lot bigger though. Okay, that's too big. Or is it? Let's take out the take out these guys for a second so we can see. Yeah, too small still. Okay. Okay, that looks flush. And then, like I say, we're going to put circles in here to fill these in. And then these ones we need to, you know, put the inverse of a circle, you know, a circle cut out of a rectangle, basically. So yeah, let's start with a couple circles. And these circles, are going to have a square cut out of them. So I believe the circle has a radius of 16. Or is it the diameter? I think it's the radius at 16. And then or no. Let's see, how do we cut that shape? Okay, well let's do this one first. These are easier. So this one, we're just gonna say, yeah, we're gonna do a circle and then we're gonna do a square. And a square. We're gonna make 16 by 16. Right, and then translate that. Let's just take a guess. Okay, yeah, that's too small and not the right shape. Okay, so it was actually an intersection that I wanted. First of all, and then that's gonna need to be rotated. So like that. Still looks too small at 16. Maybe it'll look more correct when it's lined up, I don't know. No, I'm pretty sure it's supposed to be 16 times 2. Again, don't ask me why. I'm just eyeballing this stuff. So let's see, let's translate it. Okay, that one actually doesn't need a translation. But now we're going to do another one of those. And this one will need a translation. And this one, okay, to translate, okay. Let's eyeball it. Right there. Okay, looking good. Now we need to do those two spots in here. Those are the more complicated pieces, but they should be doable. It should just be a circle cut out of a square. So maybe not that complicated, actually. Okay, so you're going to need translations and probably rotations. You're going to be a difference. And it's a difference of a square and a circle. Okay, oh yeah, and then this is going to be d equals, and let's say so I believe we're going to want a 16 by 16 square, and then the circle is probably d equals 16 times 2. Okay, now I'm imagining what I've just created in my head. So if I do a 90-degree rotation, translate it up 151 and over 250-ish. It's hard to tell where we are. Oh, here we are. That is the wrong... It's the wrong radius, first of all. Wrong diameter. $14 seems closer. Maybe it's 12 that we want? Let me back this off a bit. Still doesn't look right. No, that's definitely not right. I feel like this is supposed to be 16. But what's the actual radius of this circle? Let me see. So I'm saying r equals 16. So I do a square of r. I do a circle where diameter equals r times 2 minus 2 times z. And then intersect that with a circle where d equals r times 2. And then rotate extrude that. And then in addition to that, I'm cutting out a cube. So let me think here. I think it's the r times 2 minus 2 times z. So let's change this to be 16 times 2 minus 2 times wall C. I feel like that's not correct. Okay, this is the corner. But I can't really see through it. But yeah, basically what I want, let's line it up first, and then we'll figure out the bit we need to cut out. Yeah, so it needs to be lined up there. Right, and so this is definitely incorrect. If we go like this, maybe that is correct. Yeah, I guess that is right. Okay. I doubted it, but it appears that it actually is correct. Do worry a little bit about that seam, though. Let's see how it looks when we do a full render. we might want to give it a little bit of overlap just so that it covers the seams of the polygon. Like the circle is, approximated by this polygon with 99 sides because we set the fn variable of the fragment number to 99. So, those little gaps in between the sides, since it's a polygon, they don't necessarily line up with the ones on this other guy, and that could create a seam problem, but it's hard to know, are we just getting, render bugs, or is there actually going to be a little seam in there? Is it even big enough that it would matter for a 3D printer? There's a lot of unknowns there. But you can kind of see little seams in the model. So I am concerned about it. I just don't know how concerned I actually need to be about it. But anyway, I don't know, just to be sure, I think I do want to do something about it. So yeah, I think it is fine to give it overlap, and probably safer that it'll render as we want it to. Let's grab another one of those. Let's try to find the piece where we're working on here. Okay, there we go. Okay, and we'll call it a day once we've got this piece in place here. So I think this actually needs to be 0. This probably needs to be 294. Yeah. Okay. And then turn on all this stuff again. Okay, so with that, we now have completed our skirt. Let's take a look at the full render again. Oh, and actually not call it a day, just take a break. Yeah. So yeah, I'm gonna take a break here in a sec after we check out this final render, and then yeah, I'll be back for even more modeling fun. So yeah, this is looking pretty good. So it's got a nice, nice skirt around it. It's got this raised platform for the High Five Unleashed. And yeah, you just put our screws in all these places, and we need to add some feet so that it sits off the ground. And we need to add in you know, some ventilation holes so it can breathe a little bit for the SSD, which sits under here, and just for, you know, the whole system in general to, you know, have some holes for air to escape. But you know, it's not like the model is going to be airtight. I'm sure air will be able to get through seams, but you know, nice to have some ventilation, you know, specifically baked right into the model for the hottest area, which is the SSD. So I think that'll be smart, you know. It's maybe not the most effective because it's the bottom of the case and hot air rises, right? But I mean, it's going to hit the bottom of the, you know, bottom of the board. It's going to hit, you know, just kind of chaotically flow throughout that area, I imagine. And, you know, hopefully air escapes out of the bottom of the case naturally. We're going to try to enable it to do that. We're not going to be sticking fans in this thing or anything, so... But couldn't hurt, couldn't hurt. So, with that said, I will be right back. Alright, I am back. So, we got the skirt on this done. And I think that's all looking good. So, should we do the feet next, or should we do the walls? Let's do the feet, I think. So, where are we gonna put feet? The trick with it on this end is that this is all rounded. Yeah, okay, I know what I'm gonna do basically. So the corner piece that we stuck in here and the one in here, those little fill-ins, I think it's these guys. Not seeing that get highlighted though. Is something coloring this or what? No. So I don't know why I can't, when it's in a union, I have to like color the whole union, apparently. But anyway, I think it's these. So, oh no, those are it's these ones up here. These ones. Yeah, so I think just those corner pieces. Let me try again. If I set those to be highlighted. Does that work? No. Well, anyway, it's those two pieces. Let's just, you know, copy those and then extrude. Extrude that all down. So first of all, let's call this whole thing that we've made here like the base of it. So module base. And that's all of this stuff, which is quite a lot of stuff. So yeah, that's all gonna go in a base module, and then we're just gonna call it here. Or wait, I think some of this is not part of the base. No, yeah, it is. It's this stuff that actually needs to go farther in. All this stuff actually is part of the base module. Which is part of the case bottom. So now I can actually translate this. So I'm just going to move it up a little bit. So let's make the feet be let's do like, I don't know. Let's do 1/4 of a centimeter, so 25. All right, let's turn on our axes. So that just raises the whole thing up, right? And then we will, you know, use that to add our feet in. Okay, so it was these guys. Just copy and paste them. And these are going to go into a new module called feet. Or we're going to want 4 feet, so let's actually just make a single module called foot, and then we will, you know, do 4 of them. So a foot is going to have a single one of these guys. So the Z rotation doesn't matter. It just needs to be linear extruded by the height of the foot. Which is going to be 25. Oh wait, no, it doesn't need to be translated because we moved the model up. Okay. And let's move the model over. So that it's flush with 0, 0. Okay, I think it's going to be 16, 16. Yeah. Now this just needs to be rotated. Or wait. Yeah, this is right, but it needs to be translated. Yeah, just like that. Maybe that is a bit high. Okay, let's make it less high, I guess. Let's make a variable for that. Yeah, I think I like that. I think that looks pretty well positioned. Let's maybe move it in a little bit too. I think that'll look nice. So like, oh, wrong way. Yeah, like that. So yeah, I think I like that. Now let's put another one down. Okay, let's start with the rotation. I believe it just needs 90. This needs to be in okay, now let's get it into place. Okay, it's totally flush right there. So we want to go in by 2. So yeah, I think I like how that looks. And then we just need to extend this a little bit more out this way. And then add 2 more. And then You know, actually, we are going to need to add some more material here and here now that I think about it. Because we need to leave room for walls to actually come up from here. Which does make me wonder, maybe we don't actually want all this stuff. Because if I'm gonna have walls coming up through here, like maybe we just want this to extend and meet up with the wall actually. But that would leave a hollow region, and it talked about needing to leave escape holes for a hollow region. I don't know, that might be a problem if we have a hollow sections in the model. They might not like that. And I don't really want to make this whole thing be solid. I'm pretty happy with what I've done here. So we have some decisions to make with how we want to do that. Let me think. Okay. So, nah, I don't think I'm going to join this raised region up with the walls. I think I am just going to leave it as it is. I think that'll be fine. I think that's what I would prefer to do. So we're not going to mess with that further. We're just going to add some extensions. So first of all, the first major issue that we need to address well, let's think. How thick? We want a wall thickness of 2. I'm just thinking about the snap to fit part of it. I think I want the innermost thickness to be 2. So like, you know, the snap thing, where it comes in, like that groove, I think the farthest in I want it to be is 2. So it's actually going to be, the walls are actually going to be a little thicker than that. But we're going to cut out a region that's, you know, like that. So what kind of dimensions did they use? Can we zoom in on this? So they don't actually give us that measurement in this picture. They've used 1/4 of a millimeter. We're using 1/2 millimeter of give, you know, wiggle room is what I'm talking about. They used 1/4 of a millimeter wiggle room. We're using 1/2 millimeter. But they made the thing extend down 7 millimeters, and the top of it here is 2.5 millimeters. They didn't give us the dimensions of the notch itself. But I'm guessing that's a 2 millimeter wall thickness, and it's like 1 millimeter for the notch. If that's what they did, maybe we will keep it at 2. Interestingly, they say for in their example, in the details, they talk about that for SLA and SLS 3D printers, you can tighten the tolerance to 0.55 millimeter without much risk, which is what I'm targeting, right? But then in their picture, they had a tolerance in their design of 1/4 of a millimeter, which is smaller than what they recommend, ironically. So they do actually provide a model file, .stl. But that's, you know, this program here, I don't think it can import that. It can export to it. I don't know how it would import it. You know, it would have to translate it into code, basically. We'd have to probably look at the model in a different different program if we wanted to see what their actual specs they went with are, where all the measurements. But they do say that for an FDM printer, you should allow a larger tolerance of 1.5 to 2 millimeters. So I don't know if the bottom, I think it was the top that we saw is going to be SLA or SLS 3D printed. I think they're the ones that had the AutoTIV MFG. So what kind of, yeah, because this one is the nylon. Okay, it says it's an SLS printer. And yeah, we wanted to go with nylon. So I think we should assume everything we're doing is either SLA or SLS. So SLS. This one I just guessed. I went to the site of the. It said on the Craft Cloud thing. I'm sure it said if it was SLS or not. But when I went to the site of the company we'd want to go with, I just guessed that it would be the SLS one. So, but it said SLA or SLS. It seems like we're probably going with SLS. Okay, let me start a timer. We're gonna go for like 30 more minutes here. So, SLS is probably what we want to base our design on, SLS printing. So I think we're fine with a 0.5 millimeter tolerance. They say for if you're exposing parts and stuff like that, leave an extra 2 millimeters all the way around for that sort of thing. We're not trying to accurately do the parts, like we're just kind of going around the general areas, but that's good to know at least. So okay, here we go. It does talk about it a little bit in the description here. So what we're doing is we're doing basic internal cantilever snaps. And it says you can lengthen the amount of plastic engaging into the snap for a stronger lock, basically. Okay. So that means the bits, this bit in here, I think they're talking about the notch. They're saying if the notch is longer, then it's going to be a stronger lock, which, you know, makes sense. There are many designs for snaps, but we opted for a basic internal cantilever, however you pronounce that. Above, you can see the main details for the snap design, which is exactly the same on both sides of the enclosure. Depending on the space you have to work with, you can lengthen the amount of plastic engaging into the snap cavity to create a stronger lock. Ours is only 1.2 millimeters. Okay, so they're saying this here is 1.2. But 2 millimeters or more would be much more secure. It says, in this particular design, the pins of the PCB take up a lot of room, so the lock is designed to just squeeze in, while providing enough force to hold the enclosure together. The snap detail is extruded 20 millimeters long, which adds to the strength. So they're saying on the z-axis, basically, or the y-axis, whatever, depending on how you want to orient this. This length right in here is 20. Above, you can see a sectioned exploded view of the snap details along with the PCB showing the location of the pins in black, which limit the size of the snaps. Okay. Okay, yeah, and they designed the snaps basically from the top of the case, right? You have the wall, and then past the wall is where the snap comes down from, right? So it's really all you need to worry about is how much you want to cut in for the bit where it snaps into. That's really the only concern. So if we make it 2 millimeters, we probably wouldn't want to go more than 1 millimeter into the thing. They're saying maybe they went 1.2 millimeters or whatever. But I think what they mean by that is, there's the 0.25 millimeters of wiggle room here, and then this is like 1 millimeter in. So in total, there's like, between this and this, there's like 1.25 millimeters of space. But yeah. Alternatively, instead of the snap cavity hiding inside of the bottom enclosure, you could cut the detail through to the outside, allowing your snaps to be longer. No, that would look bad. That would look bad. We don't want to do that. Lugs are small extrusions that slide within the opposite enclosure to secure the two halves. Yeah, we'll probably do something like that at the top of it. Add lugs to your design to keep the two halves from sliding. Yeah. They say, because we created the two snaps on opposite sides, you might need these on just the two blank sides. I don't see why it matters where you put the snaps, why that would matter for the lugs. I'm not sure I follow that. Why would that matter? I guess because they mean like it, you know, if you did this all the way around and you have, you know, you have, like like say this goes all the way across and then you have a snap coming down here, right? Like it would cut through that, but you can just not cut through it. You know, you can just choose to not do that. That's not an issue. But okay, I see what they're saying though. So they added the, you know, they cut out the material all the way around this case, but then they're saying for the top half, they only cut out material for the corners, basically. Or I mean extruded material. Let me view this image up closer. Yeah, so they're saying this is, you know, 3 millimeters down. So I thought what it was going to be was like you cut out a millimeter on the outside of this, and then on the top you cut out a millimeter on the inside, right? So they snap together kind of like puzzle pieces. But it seems more like what they're saying is you cut out around the outside, all the way around the outside of this one. But then this one up here, what you do is like this, you know, this bottom portion is actually going to sit flush with this up here, right? And then what they've done is they've extruded a little lip here that's going to slot into this corner section. Yeah, it seems to be the case. Like if you look at this piece here, right, you see this is going in, snapping in here, and this has that cutaway on the bottom, you know, but then yeah, but then when you look at the top here, you see there's nothing, not like a bit hanging over here to fit into that, right? This is just gonna, like this part is gonna sit in here. So really that cutaway is really meant just to give your fingers a place for your, you know, to grab it, to pull it off, it so that it's not totally flush, basically. That's kind of what that's for. And yeah, they're just saying have some regions where it extends to fill that That's what the lugs are, to fill in that, to keep the design from sliding around. So yeah, I mean, putting them on the corners makes sense to me. I feel like we'll do the same thing. We'll just put them on the corners, right? So now the big question is how thick to make the walls, because that's a determining factor for this, of how far we can extrude in. So what did they say? 2 millimeters or more, the snap cavity, 2 millimeters or more would be much more secure. And I feel like I want it to be pretty secure. So let's make it 2 millimeters for the cavity. And then, yeah, I guess 2 millimeters for the rest of it. So really we want 4 millimeters of wall thickness, I think. I think we're actually going to go 4 millimeters of wall thickness. And then 2 millimeters for the snap cavity. So let's look back here. I think for the snaps, what I'm going to do is I'm going to put like one of them over here, one of them over here, maybe like 2 of them, so like one here, and then 2 more, one here, right? Something like that. So like 6 snaps in total. And then we'll do lugs in the corners. And we're going to want 4 millimeters overall. So just eyeballing this is like 20-ish millimeters from the side. Or, 2 centimeters. So yeah, I guess I'll move it over. Also, this isn't totally flush to begin with. Okay, so first of all, if we wanted this thing to be flush on the x-axis, Yeah, right there. Okay, now oh, because I see, I had moved it over because of where the feet are relative to it. Okay, what there we go. Okay. So I make this 18. That's back in the same place, right? But I'm actually going to want this to be 20. And then I want that in a little bit further. And the reason I do that is so that I can extend this a little bit further. Now we're going to make this thing a little bit longer. So let's find the piece we're looking at. Okay. Yeah, so I'm actually going to want to go a little bit more yet. So if I move it over there, that leaves 4, because see, like this the skirt that we created is 16, and we chose 16 for a very precise reason, right? That's not an accident. We chose 16 because that's what we made these this region that's raised up, right? That's the curve is, you know, that's based on a radius of 16 to do that. And as a result, that creates a natural, you know, curved skirt region from this, you know, like this is 16 on each side, right? And so we're going to want to add 4 around that, basically. So we want this to be in by 4 on each side, right? And now basically the result of that is we do need to change our skirt a little bit to match up with that. So okay, well, let's do the feet. Let's just not worry about the feet right now. We'll reposition the feet after we've corrected the skirt to have the correct, the extra 4 millimeters all around. Let's just focus on getting that right. So for the base of it, the ramp edges, yeah, we want to leave the ramps alone. We don't want to touch those. But there are extra pieces of the skirt Where am I doing those? That must be inside this union. That must be these. Yeah, this is the skirt stuff. Right. Yeah. Okay. Here, let's do them one at a time. So this one first. So it just needs to move down far, like that, and then it needs to be a little bit larger as a result. Yeah. Okay. But that is all I really have time for today. So I'm gonna keep doing this while I'm doing my closing statement here. But yeah, thank you everyone for watching this episode. And if you would like to catch episodes in the future live on Twitch, you can do so at twitch.risky.tv, but I can't give you any promises on when yet. Sometime after Handmade Seattle. And if you would like to watch the episodes at your own leisure, you can always do so at risky.tv, which is the YouTube archive. If you'd like to get updates about the series, you can do so at risky. At HMN_risky on Twitter. And or no, this one should be down. And then if you would like to support the series, you can do so at patreon.risky.tv. Don't have any new shout outs to do though. And with that said, I will see you in the next episode. So, see you then, and stay risky, everyone.